In a normal distribution with mean mu and standard deviation sigma, probability x is greater than 3.6 is 0.5 and probability x is greater than 2.8 is 0.6554. Write down the value of mu and calculate the value of sigma. Okay, so we're going to first standardize this. Probability x is, z is greater than 3.6 minus mu upon sigma is equals to 0.5. For the other one, we have probability z is greater than 2.8 minus mu upon sigma. When we apply standardization, we replace x with z equals to 0.6554. Okay. Our next check will be whether this z-score or this z-score is positive or negative. Okay. Let's draw a normal distribution curve over here. We have 0 over here, and it's saying that probability that z is greater than something is equals to 0.5. Without looking at the table, I know that this z's value is 0 because greater than 0, the probability is always 50% or 0.5. So you don't even have to look at the table, and you can write 3.6 minus mu upon sigma is equals to 0, or 3.6 is equals to mu. In case you were to look at the table to find the z-score for the probability 0.5, then you could always do that. At the very start, we can find the probability 0.5. And the z-score here is 0.00, which is just 0. So that's why I wrote equals to 0 over here. Okay. Moving on to the next equation given to us. Again, we have to see whether this z-score is positive or negative. Okay. Again, draw a normal distribution curve. We have 0 over here, and we know that greater than 0 probability is 0.5, but this is greater than 0.5. That means we shade some part towards the left of 0 as well, which means this z value is some negative z value. So z score is negative, which means this is actually a negative value. So we can write let 2.8 minus mu upon sigma, it's equals to some negative value. So now I'm going to rewrite this as probability z is greater than negative k equals 0.6554. This we know can be rewritten as 1 minus probability z is less than k. This can also be written as phi k. So I'm writing phi k equals 0.6554, which becomes phi k equals 1 minus 0.6554 is 0.3446. Okay. Now we're going to go to the table, find the z-score for which probability is equals to 0.3446. Okay, I just realized I made a huge blunder. This is equals to, this gets simplified to probability z is less than k. Very sorry about that. So this is just phi k equals 0.6554. Now we're going to go to the table, find the z-score for which we get this probability 0.6554. So 0.6554. Here it is. 0.6554. So the z-score is 0.40. So k is equals to 0.40, which means 2.8 minus mu upon sigma is equals to minus 0.4. So we already know the value of mu, that was 3.6. Now rearrange and find sigma from here, which will come out to be 2. Part 2. Part 2 says, if 4 observations are taken at random from this distribution, find the probability that at least 2 observations are greater than 2.8. Okay, so they're talking about 4 observation taken, and out of those, at least 2 observations are greater than 2.8. So in a way, they're talking about 2 out of 4. This is the classic case of binomial distribution. So you need to understand that part 2 is on the topic binomial distribution, where the value of n is 4 and the probability of success is the probability that the value is greater than 2.8, which is this 0.6554. Okay, so we have to find the probability that at least 2 observations are greater than 2.8. So we're going to find the probability that 2 observations are greater than 2.8, or 3 observations are greater than 2.8, or 4 observations are greater than 2.8. Or you could also do 1 minus 0 observations are greater than 2.8, and let's put brackets here, 1 observation is greater than 2.8. So I think I'll go with this approach because this would require less calculations. So 1 minus, we'll write 4C0, then probability of success, which is this 0.6554 power 0, and then probability of failure, which is 1 minus 0.6554 and power 4 minus 0, which is 4, plus 4C1 probability of success power 1, probability of failure power 3. Enter this in the calculator carefully. You'll get 0.87862, and in 3 significant figures we get 0.879.